Hello, my name is Rebekah Emery, and today we will be learning about Module 2, Sets and Whole Numbers, Number Theory, and Numerations and Computations. We have a lot of information to cover, so let's get started. We will begin by looking at Venn diagrams. Our first problem is a Venn diagram showing a union and an intersection in the same problem. To solve this problem, it is important to look at the problem carefully and to remember the order of operations. Our problem is A union B intersection C. Notice there are parentheses in this equation. If you do not regard the parentheses, you might come up with a totally different and wrong answer. First, you need to find the part of the equation that is in the parentheses, which is B intersection C. The intersection is the part of the given sets that is in set B and set C. I remember the intersection sign because it looks like the end in the word and. This helps me to remember that the intersection is only the part that is in the first set and listed and the second set listed in the problem. You will need to shade in the intersection of B and C. Next, you need to find set A, all of A, and shade in that part as well. When you have successfully shaded the intersection of B and C in all of A, you have displayed a union and intersection correctly in the same problem. Now, let's look at a Venn diagram using shapes and determine how to solve the equation using the equation C union H. The information on this Venn diagram can seem very random when you first look at it. But by breaking the information down into recognizable parts, you'll begin to see how to create union between two of the groups. Use the information that is given to you. It is given for a reason. Sometimes we are given more information than we need for a particular problem. So look at what you are given and find what you need. I need to know what C and H stand for. In the information given, I see that C means circle and H means hexagon. Now, it is relatively easy to identify a union of circles and hexagons by placing a star on each shape. To fully appreciate our modern number system, it is good to have some understanding of how number systems throughout history have been developed and used. Let's take a look at some Roman numerals. Although the Roman system of numeration is an ancient system, we still find it used today. It is found on clocks, building facades, cornerstones, historical documents, and so on. They even use Roman numerals to identify each Super Bowl. This is a very functional skill today. By reviewing the chart listed on the slide, you will see that the Roman numeral system is composed of letters, which is each representing a different denomination. I equals 1, B equals 5, X equaling 10, L equaling 50, C equals 100, D equals 500, and M equals 1000. Roman numerals are written in groups representing greatest place value to least place value, and you cannot repeat any symbol more than 3 consecutive times. So how can you show a 4 or a 9 in any place value? We do it by entering a letter that represents the amount needed to subtract from the larger number in order to display the accurate amount for that place value. Important note, you cannot subtract a number that is less than 10 times smaller than the number you are subtracting from. In other words, if you want to write 99, you cannot write IC, which is 100 minus 1. You would need to identify the tens place as XC and then the ones place as IX, equaling XC, which is 90, plus IX, which is 9, which equals 99. Having a smaller value between 2 or just in front of a greater value makes it clear that it must be subtracted instead of added. MCM. Let's find the modern equivalent for MCM XXX V11. 1, which equals to 1,000 plus 1,000 minus 100 plus 10 plus 10 plus 10 plus 5 plus 1 plus 1. Notice that C100 is subtracted from M1000, which equals 900. And our answer is 1,937. Let's switch gears and move to an alternative algorithm for completing multi-digit multiplication. I have found this method to be foolproof, especially for individuals that have a hard time maintaining straight columns of numbers, maintaining correct place value, and so on when using the standard method of multi-digit multiplication. Does that sound a bit personal? Don't judge me. Just trust me, this works. We begin by setting up a grid with the diagonal lines like the one on the slide in order to learn the lattice algorithm for multi-digit multiplication. We will systematically multiply each set of factors and record the product in the intersecting box. All products must be recorded as 2-digit numbers, so 1 would be written as 01, and so on. Each box is divided into 2 triangles. The left side is the tens place, and the right side is the ones place. So 2 times 3 equals 6. 8 times 3 equals 24. 2 times 2 equals 4. And 8 times 2 equals 16. I have highlighted alternate rows to make our next step more clear. Beginning with the ones place value, we add the numbers in each diagonal row. If we were to have a sum that exceeded 9, we would carry the tens digit to the next column. 6 equals obviously 6. 4 plus 1 plus 4 equals 9. 2 plus 6 plus 0 equals 8. And 0 by itself would be 0. And our solution is the row totals read from left to right, which would be 28 times 32 equals 896. Students often get frustrated when they are given these next set of problems to solve. They have to solve the same problem twice, such a waste of time. Why do we even need to do estimation if we know how to get the right answer, right? Wrong. I know it may seem like extra unnecessary work to do each problem twice, but both skills are actually very important. In fact, as an adult, you will probably use estimation more often than exact calculations. For instance, imagine being in a grocery store. You are in a hurry and left your phone and your debit card at home as well. You have $20 in your pocket or purse, and that's it. You have to buy enough food to feed your family in the next hour. It's not enough money for a family of 5 to eat at McDonald's, and you don't want to have to put things back at the checkout counter because the total goes over $20. You see my point? So let's estimate the answer in this problem, 883 plus 465 divided by 134. By rounding to the leftmost digit. The rounding rule says that whatever place value you are rounding to, look to the right of it. If that number is less than 5, let it ride. 5 or more, add 1 more. That means we will round 883 to 900 and 465 to 500. Because 8 and 6 are each more than 5. So we added 1 more to the hundreds place in these numbers, but 134 rounds to 100 because 3 is less than 5. So we let the 100 ride and stay the same. Now we can solve our estimation 900 plus 500, which equals to 1,400, divided by 100, which is 14. And for the exact number, which is 10.059701492533731. That we would most likely round to 10.06 or just 10. Our last concept for today will be learning to functionally perform an operation in a base other than base 10. Sound too complicated? Relax. You can do this. Once you learn just a few basic rules, you will be an expert. We are going to learn by adding 432 and 133 in base 5. Here are the rules. We basically add numbers in the same way as for base 10. However, we will only be allowed to use the following digits: 0, 1, 2, 3, and 4. And anytime we have a set of 5, it is carried over to the next place value. Look at the illustration beside the number problem. Notice that although the number totals for each place value is different. The formula for figuring the number is basically the same. We use 10 to the 0 power, 10 to the first power, 10 to the second power, and so on to get our ones, tens, hundreds, and etc. In base 5, we use the same formula, but we just change the base to 5. So we get 5 to the 0, 5 to the 1, 5 to the second power, and 5 to the third power, and so on, which becomes place values that are 1s, 5s, 25s, 125s, and etc. Moving on to solving our problem. In the ones place column, we have 2 plus 3, which equals 5. We record 0 as the answer and carry the 5 to the 5s column. Then we add 3 plus 3 and the 1 we carried to get 7, which is the same as 5 plus 2. We put 2 in this column and then carry the 5 to the next place value, the 25s. Then we add 4 plus 1 plus the 1 we carried to get 6, which is the same as 5 plus 1. We record 1 in the 25s column and carry the 5 to the 125s place value. Finally, we write the 1 in the 125s place value. So the answer to 432 base 5 plus 133 base 5 equals 1,120 base 5. The same basic rules apply for working with any other base from base 2 to base 5. See, now that you're an expert too. Wasn't that easy? You have been such a great attentive class as we have covered so much material. Thank you for listening. I'm here to help you with any questions you might have. Enjoy some new skills today, and I'll see you next time.